problem number 1. An aquarium has a rectangular base that measures 100 centimeters by 40 centimeters and has a height of 50 centimeters. And this aquarium is filled with water up to a height of 40 centimeters. And then a brick with a rectangular base that measures 40 centimeters by 20 centimeters and has a height of 10 centimeters is placed in the aquarium. And the question is, by how many centimeters does the water rise? All right. Well, let me give you a hint first. It's all about volume in this problem, isn't it? So we can find the initial volume of the water, right? We've got 100 centimeters by 40 centimeters by 50 centimeters, so we can find the volume of water. And we can also find the volume of this brick, right? So the volume of the brick is 40 by 20 by 10. And when you put the brick into the water, the volume of the brick gets added to the volume of the water, right? So the volume, the final volume that is being held in the aquarium is the original volume of the water, plus this new volume of the brick, because the brick is taking up this much volume, okay? And the other hint I would give you is that, you know, the base of the tank never changes, right? So, so that doesn't change. It's only the height of the water that's going to change, and that's what we're asked to find, is the new height of the water, essentially. Although they don't ask for the new height of the water, they actually ask how much does it rise. So if we find the new height of the water, then we can take that and we can subtract from that the old height of the water, which was 40 centimeters here, and we can find the new height. So that gives you an idea of how to approach this problem, and I'm going to go ahead and solve it. So I always like to draw a picture, so I'm going to see if I can draw a picture here of an aquarium. So we have this tank. I don't draw very well with this pen, but we have a tank, and it has 3 dimensions. It has a length and a width and a height. Okay, so there's my aquarium. And we're given that the length is 100 centimeters, the width is 40 centimeters, and the height is 50 centimeters. Okay? And then we're also given the height of the water, which is 40 centimeters. So I'm going to draw a wiggly line here, like water splashing around in the tank. And the height there is 40 centimeters. Okay? So let's start by finding the volume of the water. Okay? So I'm going to say volume of water. And what is that? It's just the length times the width times the height of the water. Now you have to be careful. You don't want we're trying to find the volume of the water and not the volume of the tank. We're going to assume for now that once you put the brick in there, that's not going to overflow. But if it overflows, if we get a new height when we put the brick in there that's above 50 centimeters, then we'll have to readjust, right? So volume of the water is going to be 100 times 40 times 40, which 4 times 4 is 16, and then I'll have how many zeros? 1, 2, 3, 4 zeros. 0, 0, 0, 0. So that ends up being 160,000 cubic centimeters, right? Okay, so that's the volume of the water. How about the volume of the brick? Volume of brick. Okay, the brick is 40 by 20 by 10. And so we have 4 times 2 is 8, and then we have 3 zeros afterwards, and that's centimeter cubed, so 8,000 cubic centimeters. All right. So the total volume when when we put the brick in the water, the total volume of both of those, I'm going to write total volume, is what? Then we're going to just add these two together, and you can see that's just going to be 168,000 cubic centimeters. Okay, so we have the new volume. We put the brick in here, and it's raised the height. We have a new volume, but the base of the tank doesn't change, so it's only the height of the water that's changing. So let's write that out. So the new volume is 168,000 cubic centimeters, and that is going to be 100 times 40 times some unknown height. So I'm just going to pretend like I know it and call it h. Okay? If we knew it, if we knew the height, we could get the volume, the final volume of the water, by multiplying them together, right? But we don't know it. We'll just put an h in there for a placeholder. Okay? So let's figure this out. I'm actually so to solve for h, we need to divide by 100 times 40, okay? Because if we divide 100 by 100, we get 1. Divided 40 by 40, we get 1. So that just leaves us with h over here. But we have to do the same thing to both sides in order for this equality to hold. So I'm going to divide this by 100 times 40. Okay? So let me scroll down and give us a little more room. So let's see. Over here now we have just h, which is what we want to find. And over here, we've got some zeros we can divide out. So if I divide 168,000 by 100, it'll just be the same thing without the two zeros at the end. And the same thing here, I can just eliminate the zeros. So essentially we get 168 over 4. That looks like it's pretty easy because 4 times 4 is 16, so that's 42 is h. Okay. Now, always go back and read what they asked for. They didn't ask for the height of the water. They asked for how many centimeters does the water rise. So, but that's easy. You just have to remember to do it. So the change in height is equal to the final height, which is 42. And the initial height is 40 centimeters, right? So if we subtract that, we'll get 2 centimeters. So the change in height, now I'm using a delta here. That's often used when you're talking about a change in something, okay? So the change in the height is just the final height minus the initial height, and it turns out to be 2 centimeters. So there you go, that's the answer.